In this video, we are going to discuss about full wave rectifier. This is one of the type of a rectifier. The basic component of the full wave rectifier is a step-down transformer, which is used to step down the AC voltage from the primary to the secondary, and it consists of two diodes, which is used for the rectification purpose, and a load resistor. Basically, a full wave rectifier is a combination of two half wave rectifier. So whenever the input signal which is coming like this, during the positive half cycle, this diode will conduct. Okay, during the positive half cycle, this diode will conduct. This will be short circuit. Okay, because this is plus and this is minus during the positive half cycle. Okay, during this positive half cycle. Okay, so this is the signal. This is the diode becomes short circuit, and I'm getting the voltage. I'm taking the voltage across this one. Okay, this is your V0. The same signal will appear here. So during the negative half cycle, this is positive and this one is negative. Okay, during the negative half cycle, so this diode will be short circuit and this diode is open circuit. Okay, so the current will flow like this. Okay, in this direction. Okay, so you can see I'm getting the output in the same direction. Okay, for the positive half cycle and also for the negative half cycle. Okay, so instead of the negative voltage, I am getting a positive value. So I can write V0 is equal to, this is nothing but Vm sin alpha. Okay, Vm is a peak voltage, Vm sin alpha, which is ranging from 0 to pi, and from pi to 2 pi, it is minus of Vm sin alpha. Okay, so this is the inverse of this one, right? So minus of Vm sin alpha for the period pi to 2 pi. So if I want to find the mean value, okay, VDC is equal to 1 divided by 2 pi. 2 pi is my total time period, and 0 to 2 pi, where 0 to pi it is Vm sin alpha, and from pi to 2 pi it is minus Vm sin alpha. So if I take a Vm common, and if I integrate sin alpha, I will get minus cos alpha. So we know that cos pi is equal to minus 1 and cos 0 is equal to 1. Okay, so you substitute the value. So if I substitute the value, I will get 2 Vm by pi. Okay, so next one is you need to find the value of root mean square value or effective value. Okay, effective value or Vrms value, that is equal to root of 1 divided by 2 pi to 0 to 2 pi, so the square of the this value. Okay, d alpha. So if I substitute this value, I will get this one, and we know that cos 2 alpha is equal to 1 minus 2 sin square alpha. Okay, so from this I can write sin square alpha is equal to 1 minus cos 2 alpha divided by 2. Okay, so now if I integrate this one, 1 if I integrate, I will get alpha, and cos 2 alpha if I integrate, I will get minus cos if I integrate sin 2 alpha divided by 2. Okay, so if I substitute the values, I will get this equation, and on solving this one, I will get root 2 pi. So this pi and pi will cancel out, and root 2 by 2 is equal to this. I can write like this. Okay, so this will cancel and I will get 1 by root 2. So the Vrms value is equal to Vm by 2. In the similar way, Irms value is equal to Im divided by root 2. Okay. So next is full wave rectifier efficiency. If you want to find the full wave rectifier efficiency, this usually we are going to find it in the percentage. Okay. So you have to multiply this one by 100. Okay. So this is nothing but output power divided by input power. That is nothing but IDC square RL divided by IRMS square RL. Okay. So if I substitute the value, I will get 8 divided by pi square into 100. That is nothing but 81.13%. Next one is a ripple factor. Ripple factor is nothing but the AC component which is present in the DC. Okay, so the formula is root of Vrms divided by Vdc the whole square minus 1. So you substitute the value of Vrms and Vdc, you will get 0.48. So compared to the half wave rectifier, we are getting a very less ripple in the full wave rectifier. So this is one of the advantage of why we are going for the full wave rectifier. Next, transformer utility factor. So this is defined as the ratio of DC power delivered to the load to the AC power rating of the transformer secondary. So first you have to find the value of the secondary value and also for the primary value. Okay. So this is nothing but AC power rating of the transformer. Okay, so I can write this one as IDC square RL divided by Vrms IRMS value. So if I substitute these values, and I will get 8 divided by pi square, that is nothing but 0.812. So this is for the this is at the primary side. Okay, this is a for full wave rectifier at the primary side. Okay, that is 0.812. So next, if I want to find it for the secondary value, so transformer utility factor for the secondary value is twice the times of the transformer utility factor of the half wave rectifier at the secondary. Okay, that is nothing but 2 into 0.287. This is a transformer utility factor for the half wave rectifier. So you will get 0.574. So if I find the average of these two values, that is secondary value and primary value, I will get the TUF of the full wave rectifier. I will get, that is nothing but 0.693. Okay. Next is form factor. Form factor is nothing but a ratio of the RMS value divided by RMS voltage or current value divided by IDC of the current or voltage value. That is equal to Im divided by root 2 divided by 2 Im divided by pi. So if I solve, I will get pi divided by 2 root 2. Next one is a peak inverse voltage. So if you see during the negative off cycle, the diode D1 is open circuited and the diode in the downside is a short circuit. Okay, so because of this one, I will get the whatever the voltage that is here, that will be produced as output, right? So here I will get the voltage as Vm. So I can solve this as this is your negative value, and this is open circuited and this is short circuited. Based on this value, I will get the value of output as across the resistance. I will get the output as Vm. So if we solve this one, minus Vm is equal to Vd1 plus Im. So if I solve, I will get Vd1 is equal to minus 2 Vm. Okay, so what is Vd1? Vd1 is your peak inverse voltage, that is equal to 2 Vm. So this is one of the disadvantage of the full wave rectifier. So the breakdown voltage for this one is should be greater than the 2 Vm value. So this is one of the drawbacks of the full wave rectifier. Okay. So I hope this video is useful for you. Thank you very much.